Hello everyone, welcome to MRU E-Learning powered by Malla Reddy University. I am Munni Sheikh from IT department as well working as assistant professor Malla Reddy University, Hyderabad. So today I am presenting introduction to hashing, hash functions, hashing collisions, collision techniques. So my agenda, first of all, I am discussing about the introduction to hashing, components of hashing, applications of hashing, direct address table, advantages and limitations, types of hash functions, hashing collision, and collision techniques. So before start about the hashing, so hashing is one of the main component in data structures. So as of we know that data structures, we are having two types in that linear data structures, non-linear. So in linear, we are having stacks, queues, and linked list. Coming to non-linear, we are having the trees, graphs, and hashing. So now I am discussing about the hashing. So what is the hashing? So hashing is a technique in data structure to store and retrieve data efficiently. So here we are focusing mainly here about efficiency. So hashing involves mapping data to a specific index in a hash table. The great thing about hashing is we can achieve all three operations such as search, insert, and delete. So hashing is mainly used to implement a set of distinct items and dictionaries. So, why use hashing in data structures? Hashing is a method for reducing the search time of data and keeping it more secure. It helps us find data much faster than our original data structures. So, generally, in library or in databases also, in hospitals also, in college also, if any data we want to search the data. So, using the hashing, the time complexity will be going to reduce. That's why we are using the hashing here. So, see the diagram. So, how we are finding the hashing. So, how we store the data in the hash table. So, in the diagrammatically, see the list. So, we are having the elements 11, 12, 13, 14, 15. So, here I have use the hash function. So, we have the four types of hash functions. So, in this hash function, this is the division modulo method. So, division modulo method formula, we have the hex mod 10. So, if we can calculate 11 mod 10, then we will get the remainder 1. So, in the 1th place, we can store the 11. Like that, 12 mod 10, 2nd place, 13 mod 10, 3rd place, and 14 mod 10, 4th place. And like that, 15 mod 10, 5th place. So, this is the example diagrammatical of about the hash table. Above diagram, so we have observed there are three components of hashing is there. So one is the key, one is the hash function, one is the hash table. So what is a key? So what are in the before diagram? So what are the key elements? I have taken 11, 12, 13, 14, 15. So this is we have taken as the key elements as the input. So these elements can be put into the hash function. Then hash function can be produce this output. So according to this output, we can store the data in the hash table. Like this. So key is nothing but the input here. Hash function means we have the four hash functions: division method, modular method, multiplication method, and mid-square method. So in hash table means whatever the results came, that we can store in the hash table. Now diagrammatically see here once again. So we have here, this is the key elements like input I said just before. Then this is the hash function. So hash function we have the division method, mid-square method, multiplication method like that. So whatever the result produced, this is as a key index we have taken. According to the key index, we can store the values in the hash table. So now see the applications of hashing. So hashing is used in various applications in computer science such as storing and retrieving data quickly, implementing data structures like hash tables and hash maps, searching and indexing data efficiently, ensuring data integrity and security, and password hashing and encryption. These are the applications of the hashing. Now, direct address table. So, what is a direct address table? So, direct address table is a data structure that has the capability of mapping records to their corresponding keys using arrays. So, in direct address tables, records are placed using their key values directly as indexes. They facilitate fast searching, insertion, and deletion operation. So, let us see example. So, list of elements I have taken like 20, 21, 22. So, if I want to store the key element 21, so for example, see take the elements 10, 20, 21, 23, 24, 25, like this I have taken the elements. So for example, the hash table size I have taken like 30 is the hash table size. So 0, 1 and so on like this. 30 is the size of the table. Then here 10 means directly 10th place we can store the 10th value. 20 means 20th place we can store the 20 key value, like the 21, like that 23, 24 means what we understand here. So whatever the key element you are taking as the input directly, that you can take as the index. So whatever the key element we have taken, like 10th place we can store, 20 means 20 place we can store, 21 means 21th place we can store, and like this 24, 25, like this the elements. So in this diagram also if you can observe, so key element 21 means 21 placed at the 21th index. So this is about the direct address table. Next, what are the advantages and limitations of the hashing? So mainly the advantage we are having, searching, insertion, deletion, or the time complexity of the hashing is the O of 1. Okay, constant time complexity we have. So compared to the linear search and binary search, the time complexity is the O more there. But compared to here, it can be reduced the time complexity. So because of that, we can use the hashing here. So the limitations we have, it can take the more wastage time. So and the hash table size also we don't know particularly, we have to take the maximum size there. So that is the drawback of the hashing. Next, now I am discussing about the types of hash functions. So we have here 4 methods: division method, mid-square method, folding method, multiplication method. Now see the division method. So the easiest and quickest way to create a hash value is through division. So the k value is divided by m in this hash function. So what is the formula? See the formula h of k equal to k mod m. So where k is nothing but the key value. So whatever the elements input as you are taken, that is the key value, and m is nothing but the size of the hash table. So let's assume the size of the table like 10, 20 according to the table size. So then here the element key element 17 I have taken, then 17 mod 10. So 17 mod 10 is nothing, the remainder value we have taken here 7. Okay, so 7th place we have to store the key element 17. So this is one more example of the digital modular method. So in this elements, key elements I have taken 99, 158, 295, 96 and 5092. So according to this, so 19, the table size I have taken 10 here, then 19 mod 10. So 19 mod 10 means we can, the remainder value is the 9. Okay, in 9th place we can store the 99 value. Like this, if you can take 90 also, the remainder will becomes here 90, 0th place. Okay, 90 can store here 0th place. So like this we can store the division modulo method. Next we have the mid-square method. So the following steps are required to calculate this hash method. So k into k or square the value of k. So what is the formula? See the formula h of k equal to h of k into k, where the k is nothing but the key value. So example of mid-square method. So if I am taking the k value 60, therefore 60 into 60. So 60 into 60 means here the value we have 3600. So in 3600 we have to take the middle value. Okay, so this is the place of the key index. So in this place we are storing the value, key index value. So now see the example diagrammatically we have here. So the keys we have 99, 158, 295, 96 and 5092. So hash function. So what is the formula we are having? K into k. So for example, if you take a 90 into 90, 18100 is the mid square. Then 10th place we can store the 90. Next we have the folding method. So the folding method we have here, the process involves 2 steps here. So we have to take the k value, like divide into the multiple components such as k1, k2, k3 and so on kn. So K equal to like K1, K2, K3, K4 and so on Kn. So S equal to K1 plus K2 plus K3 plus and so on Kn. H of K equal to S. So where S equal to addition of the parts of key. So example, if the K value I have taken 1, 2, 3, 4, 5. Then K1 equal to 12, K2 equal to 34, K3 equal to 5. So means we whatever the key element we have, we are dividing the components. Okay. So like K1 equal to 12, K2 equal to 34, K3 equal to 5. So then S equal to what is formula? K1 plus K2 plus K3 plus K4. So that means 12 plus 34 plus 5, 51. So H of K equal to 51. So 51 the place we can store that element. Next we have the multiplication method. So determine a constant value where A is the constant and where A 0, A, 1 also constant. So add A to the key value and multiply. So consider K as fractional portion. So multiply the outcome of the preceding step by M. So now see the formula H of K equal to floor of M into Ka mod 1. Okay, so where M is nothing but the size of the hash table, K is nothing but the key value and A is the constant value. Okay, now let's see the example here. So if I am taking the K value 5678, so A is the constant value. So constant value we have to take 0.6829. M is the hash table size. So table size I am taking 200 here. So now calculating the new value here, H of 5678 equal to floor of 200. So hash table M is nothing but the hash table size here. Then the key value into constant A is the constant value and mod N. So according to this formula, we are getting the key index here 114. So now, before we have seen the 4 functions, that functions like division modular method, middle square method, multiplication method, distinct folding method. So using that methods we can get the collisions. So what is a collision? So in hashing, hash functions were used to generate hash values. The hash value is used to create an index for the keys in the hash table. So the hash function may return the same hash value for 2 or more keys. When 2 or more keys have the same hash value, a collision happens. So now see the here diagrammatically. So if I am taking the key value 10 and key value 15, then here the hash of 10 equal to also 0 and hash of 15 also 0. So division method formula here mod with the mod 5 we are doing the calculation, then we are getting the 0. So for 10 also, for 15 also we are getting only 0 index. So that means for the same key elements we are getting the same key index value in the hash table. So this is called as a collision. So in collision resolution techniques we have the 2 types here. One is the separate chaining and one is the open addressing. Okay. So now see diagrammatically, separate chaining is also called as a open hashing and open addressing is also called as a closed hashing. So in this again open addressing have 3 types here: linear probing, quadratic probing and double hashing. Now see one by one. What is a separate chaining? So the idea behind separate chaining is to make each cell of the hash table point to a linked list of records that have the same hash function value. So chaining is simple but requires additional memory outside the table. So we have given the hash function and we have to insert some elements in the hash table using the separate chaining method for collision resolution technique. So here, so the main hash function formula we are using division modular method key mod 5. Okay. So elements I am taking 12, 15, 22, 25, 37. Now see the example here. So first we are taking the size of the hash table is the 7 here, key mod 7. So this is the division method formula. So the main method we are using in the separate chaining also, in any other technique also we are using the division method formula only. So I insert the following sequence of keys in that. So I am taking the values 50, 700, 76, 85, 92, 73 and 101. So first draw the table. So this is a table we have. So table size is the 7 here. So draw step 1, draw an empty hash table. So for the given hash function, the possible range of hash values is 0 to 6. So means the index will be start from the 0 and the size is here, last element place is the 6th. Okay. So draw an empty hash table consisting of 7 buckets as. So step 2. So first element we have taken the 50. So 50 placed here. 50 mod 7. 50 mod 7 means we get the 1. Okay. So 1 we place, we store the 50 element. Okay. Next element we have taken the 700. So 700 mod 7 means the remainder we got the 0. So 0th place we have stores the 700 value. Next we have the third element 76. So 76 mod 7. So we got the 6. So 6th place we stores the 76 value. Next we have the 85. So 85 mod 7. So we got the 1. So 1 already we stored the 50. Okay. So the bucket is filled. So here now collision happened. So in the separate chaining concept, we are using the linked list concept. So whenever the collision occurs, we stores the value. We form the links here. So 85. So then we stores here 85. Next element we have the 92. Okay. So 92. So again 92 mod 7 means 1 getting. So 1 means already 50 placed. And second we stored here 85. So again one more collision got here. Then again we form the link. One more link here. So 92 placed here. Next element we have taken 73. So 73 mod 7. 73 mod 7 means we got the third place. So third place is empty. Third bucket is empty only. So that's why we stores the 73 here. Next last element we have the next 76. So 76, next element we have the 101. So 101 mod 7 means third place. So third place already filled. So that's why again link formed here. So 101 placed here. Okay. So that is about the separate chaining. Next we have the open addressing. So in open addressing, again we are having the 3 types here: linear probing, quadratic probing, double hashing. So in open addressing, we are having linear probing. So what is linear probing? In linear probing, when collision occurs, we linearly probe for the next bucket. So we keep probing until an empty bucket is found. Okay, so advantage we have, it is easy to compute, and drawbacks, the main problem with linear probing is the clustering. So the main consecutive element form groups. So now see the example of the linear probing here. The previous separate chaining also, for a main formula we are using K mod M division method formula only we are using. Here also, when collision not occurs, we are using the formula K mod M only. If the collision occurs, then we are using here K plus 1 mod M. If the collision occurs, then we are using the formula K plus 1 mod M. Okay. So the elements, first element we have taken the 50, the hash table size 7, 50 mod 7, 1. First place 50 stored here, and second element we have taken 700. So 700 mod 7 means 0. So 0th place we stores the 700. Then third bucket, third element 76 mod 7. So we got the here 6th. Okay, 6th place we stores the element. 85 mod 7. Okay, 85 mod 7 already we got the first place, we stores the 50th element, and so now we have to do the K plus 1. Okay, K plus 1 mod M. Okay, so then next place K plus 1 means this bucket is empty, so 84 is stores here. Okay, and next element we got 92. So 92 mod 7, 1. So 1 already 50 we stores. So again plus 1 means 85 already stored. Then again we have to do plus 1. K plus 1 means then here we have the 92. Okay, so 92 is stores here. Okay, like this we use the linear probing concept. Next we have the quadratic probing. Okay, so quadratic probing is an open addressing scheme where we look for ith slot in the ith iteration of the given hash value. X collides in the hash table. So let a hash of X be the slot index computed using the hash function. So if the slot of X mod S is full, then we try hash of X plus 1 into 1. Mod S. So simply easy to understand, generally K mod M is the division modular method. If the collision not occurs, then we are using this formula. If collision occurs in the linear probing, then K plus 1 mod M we stores here. We are taking. In quadratic probing, we are taking K plus I square. K plus I square. Okay. So now see the example here. So step 1. So empty hash table I am taking. Then 22 mod 7 means 1 stores here. Then step 3, so 30 mod 7 is second place, 30 stores. No collision occurs. Now step 4, so the element we have taken 50. So 50 mod 7, 1. So 1 already here filled. So first time collision occurs means here. Then we have taken here k plus I square. So 1 plus 1 square. 1 plus 1 square means the second place we stores the next element. Okay. So if the collision occurs, then I value will be going to increase. So 58th element will be stored. So 1 plus 2 squares. Then 5th place, 1 plus 4 means 5. 5th place, this element stores. Now next we have the double hashing. So double hashing formula we are having h of k equal to h1 k plus I into h2 k. Okay, so h1 k is nothing but normal division method formula only, division modular method formula only, k mod m only, k mod m we have to find here. And h2 k means here prime number minus k mod prime. Okay, so the prime value we have to take the nearest hash table size. So for example, the hash table size 10 I am taking, the prime number should be take the less than the hash table size 7. Okay, like this we can take the h2. So now see the double hashing example here. So step 1 empty bucket, step 2 27 mod 7 6th place we stores. Then step 3 43 mod 7, so 43 first place we stored. Then next we are having step 4. So step 4 692 mod 7 6th place. So 6th place we stores the 692 already filled. So that's why we applied the formula. So then we got the here value second place. Second place we store the 692. So like this we are applying the formula for double hashing. So conclusion, so linear probing has the best catch performance but suffers from clustering. Like quadratic probing is lies between the two in terms of the catch performance and clustering also. So double catching has the poor catch performance but no clustering. This is about my concept. Thank you.